You know that feeling, right? You're deep in a conversation with an AI. Maybe you're building something complex. And then, poof, it completely forgets what you were talking about 5 minutes ago. It's a huge, incredibly frustrating problem. Well, today we're going to dive into a totally new way of building AI that's designed to solve exactly that.
All right, so let's get right into it. This is a problem that anyone who's really tried to push a chatbot to its limits knows all too well. It starts out seeming like a genius, a perfect collaborator, but as you keep feeding it more and more information, you can just feel something start to break.
This quote from the source material it hits the nail on the head, doesn't it? It perfectly captures that feeling. It's not just forgetting one little detail. It feels like the AI's entire ability to reason is just degrading in real time. And you know what? It's not just a feeling. It's a real, measurable thing.
And there's a technical name for it, context rot. It's this idea that the more you try to stuff into an AI's short-term memory, its context window, the worse it gets at its job. And we're not talking about a small dip in performance. For anything remotely complex, it can be a total collapse.
Now, what's so fascinating here is how this whole problem breaks down. This is one of the key insights from the research. If you ask an AI to do something simple, like find a single needle in a haystack, it's actually pretty good at it, even if the haystack is enormous. But the moment you ask it to do something more complex, something that requires connecting different pieces of information, its performance just falls off a cliff as that conversation gets longer. And this happens even to the most powerful models out there, like GPT-5.
So, how do you fix this? Just trying to build bigger and bigger context windows brute force, it's not really cutting it. The real solution, it turns out, is a really clever shift in perspective. Instead of trying to give the AI a bigger desk to pile all its papers on, what if you gave it the keys to an entire library?
And this, right here, illustrates the core idea perfectly. A standard AI tries to cram the entire massive conversation onto its tiny little mental desk, and it just gets completely overwhelmed. But a recursive language model, or RLM, does something different. It treats that long conversation like a library. It doesn't try to read every single book at once. Instead, it learns how to use the card catalog to find exactly what it needs, right when it needs it. This diagram shows you kinda how it works. See, that long prompt, that huge wall of text, isn't fed directly into the AI's brain. Instead, it's treated as an external environment. That's our library. The AI can then write its own little bits of code to explore this library, pulling out small, relevant snippets. It can even call on smaller helper AIs to analyze just those specific pieces. It's a total game changer in how the AI interacts with information.
So, how does this AI actually use its library card? It's not just wandering the stacks aimlessly, right? No, it thinks and acts like a super efficient programmer, using a few key strategies to hunt down the answers it needs.
Let's walk through its process, because it's really cool. First, it just peeks at the data, kind of like a programmer would, just to get the lay of the land. Then it filters by writing simple code to zero in on what it thinks are the most relevant parts. After that, it decomposes the big question you asked it into a bunch of smaller, bite-sized questions. And here's where the real magic happens. It then calls for help, handing off each of those tiny focused subproblems to a helper AI.
And here's a perfect example of that filtering strategy in action. The RLM is given this massive document. Instead of trying to read the whole thing, which would be a huge waste of time, it just writes a tiny piece of Python code to search for specific keywords it thinks are important. It's intelligently narrowing down potentially millions of words to just a handful of critical sentences.
And this right here shows that next step beautifully. Once it's found a little snippet that looks promising, it doesn't try to analyze it with everything else in its head. No way. It makes what's called a recursive call, that LLM query you see. It basically calls up a helper AI and gives it one super small, super focused task, like, hey, from this one paragraph, tell me the winner's name. And that move is what lets it completely sidestep the context rot problem.
Okay, so this whole process of peeking, filtering, and delegating, it sounds really smart in theory. But does this clever approach actually work any better in the real world? Well, the researchers put it to the test against a big, powerful standard AI, and the results were honestly just stunning.
So they use this really tough industry benchmark, one that's specifically designed to cause context rot by making an AI connect thousands of pieces of information. And just as you'd expect, the standard GPT-5 model really struggled, but the RLM, oh, that was a whole different story.
Okay, get ready for this. The Recursive Language Model, using the smaller GPT-5 mini model, saw a 114% performance increase over the full, more powerful GPT-5. Let that sink in for a second. A smaller, cheaper model
just by using the smart library technique, didn't just beat the bigger model, it more than doubled its performance. Incredible.
And here is the knockout punch. You would think that this complex recursive process would be crazy expensive, right? Well, it's not. As you can see here, the average cost for each question was actually cheaper than just using the big dumb model. It's not just smarter, it's more efficient. It only reads what it absolutely needs to. So what's the big takeaway from all this? I think it's that brute force isn't the only answer. We don't necessarily just need bigger AI models with bigger and bigger context windows. We need smarter models that actually know how to use the information they're given.
So, the crucial point is this. Recursive language models are a massive leap forward. We're talking about models that can handle inputs 100 times larger than their built-in memory allows. This opens the door to analyzing entire company codebases, massive research libraries, or even years and years of chat history, all in a single go. And all of this leaves us with a really fascinating question, one that the researchers themselves posed. We've already seen AI get smarter with step-by-step reasoning. So is this recursive, self-delegating approach the next huge paradigm shift? Looking at these results, it really seems like we might be witnessing the moment the forgetful genius finally gets a perfect memory.